So this is the application repo. So here so if you remember from what we all said, the main idea is to create vector for the objects in the RGW buckets in a vector DB. So here we are using a middleware system. So you can see I have created a middleware standalone pod, and so this is a ECTD pod which is used by the middleware. Then I have created a Ceph cluster using Rook. So you can see also like there's an RGW server running and the basic Rook cluster things. Okay, now so after configuring this, I need to also configure Knative. I have configured Knative, and so these two are for the Knative eventing, the ports which take care of it. And I need to create a default channel to receive the notification. So this one is in-memory channel, as you all mentioned. We can also switch to Kafka. So basically, uh, yeah, for that I need to have these two ports or this configuration. Okay, so that's a prerequisite, and I am running a Minikube cluster in my environment. Now, if we look into the repo, there are three YAML files actually for. First one is related to the Knative resources. So this one has like the information about the channel, and I'll create a subscription. So the subscription basically tells uh, the service which my application running to listen to the channel. So basically that's how they are linked. So I'm trying to deploy two applications, one for test and one for image. Ideally, it should be an operator, so which can handle multiple types of objects, or like basically I need it will be different ports, but still like it is better to configure as an operator. So each port will be handling different types of objects. So that's the basic idea. Uh, I have already created the resources. So other one is next one is book resources. So here, okay, I have topic. So this is a reference for the channel which I have created in the topic, so that actually we can send a notification. And there are two channels, one for image and one for text. And yeah, so this is a notification, and currently I'm listening or getting notification for put and copy operations. Basically, when a object got created, I will create a vector on the vector DB. So that's the idea. Please feel free to stop in between if you have doubts or something like that. Okay. And so OBC is a Kubernetes resource which will create a bucket, RGW bucket on the backend. So yeah, I have. So here you can see the notification is also referenced, so that while creating the bucket, like it will link with this notification, and the notification will be sent when object is created on this bucket. So yeah, so that's the basic configuration for RGW. And as I mentioned, I have two ports. So two application, one will listen to test and other will watch for image. Again, this is uh, basic port configuration, which these are the sources which will be used on the port for accessing RGW and all. So you can see I have created a service, and this service is used to like get the information from the channel and pass to the uh, port. So these are the basic configuration for the port. So one is the middleware endpoint, which will be shared as a configuration. And I need to mention which type of object which are handling. So vector dimension is related to the embedding function. So here the function is from sentence transform, and they have a vector dimension of 384. uh, and image is from PyTorch. Again, it has like so both are different dimension. If you're using a different type of uh, embedding function, the vector dimension will change. So again, this is input. We need to get it from the user so that the collection can be created on the middleware packet. Okay. So at the moment, yeah, I have both application running. I have just created before the meeting. So okay, and uh, I can also show you the subscription if you want. So these subscriptions are already, yeah. So everything is ready, and now I just need to. So I have an AWS TLI client running on this machine. Now I need to access the RGW bucket and also I'm exporting some variables or configuration from the uh, RGW, from the circuits in the Kubernetes world. So first thing is, oh, okay. What happened? Hello, am I audible?
Yeah, we can hear you.
All good.
Okay. I don't know, this got freeze. Okay, hold on. I'll get it here. Yeah. My terminal is kind of stuck. I don't know. My gosh. My computer got hanged. I'll try it in a new window. Something weird is happening with my keyboard. Okay, sorry guys, but I do have backup. Uh, I'll try to. So, you all, can you share the screen and show the demo? I think my keyboard or like the keys are not getting activated. Can you please show the demo from the like the video? I will
Sure.
try
I
to.
think you see on your upper right corner, there's this
Oh,
small image like of a person. Can you click that? I think this is yeah,
slow keys.
yeah.
Okay. Ah, fine. Thanks. Okay. Sorry. Okay. So just I need to uh, set up for my client. One more thing, I have exposed the RGB service to external port in my VM so that I can access it from my VM. Otherwise, I need to have a container to access the RGB service. So, so this will give me the IP address of that uh, RGW service. So basically, this is the IP of the container, like IP from the container system, and this is a port on my VM. Okay. Now I need the access key and secret. So first I'll do the demo for the test. So this will be okay. I also need the bucket name. Okay. Now Just a second, I'll come in 2 minutes, 1 minute. So the bucket is empty. So I have sample data over here. So basically, these are from Ceph for related RGW documentation, and I am just copying the contents. It will take some time. So if you check the logs here, okay. Yeah, so basically it's uploading all the data, and I think they're still creating the vectors. So that's why it is taking a bit time. Okay. So yeah, these are the sample vectors which is getting created. Okay. Now this is the collection name. So I have a search program, Python program, which will basically search the uh, in the vector DB. So for that I need the collection name. Okay. Now other thing is again similar to exposing RGW service, I need to expose Milvus so that it can be accessed by externally basically. So I am doing a port forward. Again, these are the Kubernetes things to do exposing the service. Okay. So I can access the Milvus endpoint via localhost and on this port. Okay. So this is my search program. So it has three inputs. One is the Milvus endpoint, and other one is the collection name, and third one is the test which I need to search. So yeah, basically it again create a query vector based on the embedding function, and it will search the query vector inside that collection. Okay. Now I'm doing a sample search. Sorry. So yeah, you can see like this yeah documents related to Vault and multi-site S3. So for the time being, I'm just searching thing in between two zones. So this is my search test. And if I do here, copy the layers. This one. Just a second. I think I have copied it a bit wrongly, the collection name. Okay. So yeah, it resulted two entries. So I'm just searching for the uh, best match too. So you can see the first one is like the multi-site thing, um, the first match, and second match it says cloud transition. Maybe I can select it to replicating data or mentioning two zones or something like. Okay, so that's for the test search. If you guys have time, I can do the demo for the image as well.
Yeah, plenty of time.
Ah, sure. Okay, then I'll do the image. So image, I'll just show it from the UI, the data, because from terminal, I don't know whether it will be understandable. So just okay. So again, this is my sample data. You can see I have pictures of the baby animals like ape, cow, dog, squirrel, tiger, and all. And for searching purpose, I have created two search images. So this is kind of big, like the actual elephant and tiger. Okay. So similar to the search program, I have image. Again, similar input like. So basically, the embedding function, like it need to be changed accordingly. So here I am using different embedding function. So that's added here. And again, I have three inputs. One is the Millicent point collection name, then the image. Mm. So this is like a class which do the embedding part. Yeah. Okay. So first again I need to export the access key bucket name and all for the image bucket. It will just take us some time. LS. So the bucket is empty. Again, I am copying the data. Very cancel. I will just show the logs first. I should have done it for them. So here the no logs received or like no request received. So the log is pretty much empty. Yeah. Okay.
Jiffin, one question.
Uh,
You don't use persistent notifications here, right? Because this is why it takes so long,
yeah,
because
yeah, I
the the
have configured.
latency of the sending notification is inside the uploading of the images, right?
Yeah, yeah, but I have enabled the position notification. I think it is not async.
Mhm.
So basically, yeah, that's why the latency is bit. Yeah, so I have uploaded the data again and doing it. Again, I need the collection name. Basically. So the collection name is created from the bucket. So Milvus has some condition. There should be only underscores as a special character for the bucket name. That's why. So ideally, we must like it should be related to bucket. So since the Milvus has bit precision, yeah, I just need to copy it from the logs. Like, okay. Again, I can see the logs for yeah, all the vectors will be added. Basically, okay, paste. No, I didn't copy. Okay, so if I do the searching of elephant, yeah, the first URL points to an elephant. The second one is pointed to koala. I don't know. Maybe it looks a bit similar. If I do, oh, okay, if I do the search of tiger, yeah, again the first entry is tiger, baby tiger. This one is, I don't know. Maybe that's a similar one. This one is in koala. Okay, so that's pretty much I have to do in this demo. Any questions or like any?
That's really cool.
Okay, so I am stop sharing. Thank you.
Thanks, Jiffin. That was great. I would like to add a couple of comments of things I didn't mention last time, which are maybe more relevant to actually this team, because like what Jiffin showed here is using building blocks that we already have in Rook and Ceph and in the RGW. The big question, and this is something that we're not yet decided on, is do we want to kind of take on us also the search part? So this is the ingest part, and it's automating the vectorization and all the mechanisms for that would make sure that the vector2b is synced with the data uploaded to through the RGW and in a way that is automatic and but as you see in here, the search is completely unrelated. It's a Python program or any other program that does the search. There were some people that were saying that the search should go also through the RGW. Now, in theory, it should be possible. For example, Milvus can have S3 as the backend to store its indexes, which means that we actually can have access to the indexes. And they have an own format that, in theory, we can read, and it's a Parquet-like format for storing the indexes. And because we own the data anyways, then in theory, we can extend the S3 API to have something like a search verb that would just return, do the embedding for the search term, which could be an image or text or anything, do the search and just return the value instead of going through the actual vector2b, doing a search and getting the URL for the object, then going and fetching the object. Now again, the plus and minuses in taking the search part into the RGW or not, and also this would require some significant development effort because it would mean that we're going to have a module that understand the indexes, and we'll figure out how to do that in a sharded way and scalable way and so on and so forth. So there are many challenges there, but there's also value in doing this. So that's the main open question that I think remains here regarding the vector2b integration.
So if you ask Milvus directly, it just gives you a link to a URL in S3. What's the advantage of RGW doing it?
So there are a couple of advantages here. First of all, the user doesn't have to deal with two systems, right? They uploaded the data into the RGW, and maybe they want to also search the RGW. So they have one point where they authorize against and communicate with and deal with, both for data retrieval and for storing the data. There's another issue here, which is that we can make sure that everything is configured correctly. For example, in the program that we run in Knative based on that is triggered by the bucket notification, we have an embedding function. So we do embedding for the image, and then we create the floating point vector, and we store it in Milvus. And when we do this, but this is something that is kind of behind the scene from the user perspective, because once we have an operator and everything is done nicely, they don't even know about this. Like, everything is hidden from them. They just define some YAML and everything magically works. Now, if the embedding function or the dimensions of the vector doesn't match in the ones used in the search program doesn't match the one that was used when we did the embedding, then nothing works. And if we are the only entry point to the whole system, then we can make sure that everything is in sync. So all this configuration, we own it, we store it, and there could be no discrepancies between the way that we embed the vectors and the way that we search them. Another thing, so this is less related to textual searches, but more for image searches. So in the image search, the embedding of the image could be a challenge for itself for the client. Now, it could be that the image to search for is also stored inside our system. So in theory, if everything is stored inside the system and you do a search, a similarity search for an object that already exists inside the RGW, then you don't need to embed it and process it and do all that work again. You just say, okay, give me all the objects that are similar to some object. And then everything is done behind the scene, and there's way less work that is being done to fetch the correct object. So there are a couple of issues. The main drawback is that the Milvus, like, they have an API that is designed for that, and S3 doesn't have an API like that. And trying to kind of reinvent such an API for S3 could be, a bit of a problem, or architecturally wrong to try to invent something like that. So that could be the main reason why not doing that, or why it could be issues.
Do we think that the same set of applications will be doing the uploading and the searching, or will the uploading be done by one set of applications and the searching done by a different one?
So that's another point. I think in many cases, those would be completely different applications. So one set of applications would do the upload, or the application that are doing the upload could be completely unrelated to the AI applications or the data scientists doing the searches. And in this case, maybe there's absolutely no reason or behind. I mean, data scientists or people interested in the data, which is vectorized and everything, would define that they're interested in the data. They will express that in the CRDs, in the YAMLs, and that would make sure that everything is done behind the scenes. But they write the application that does the search, and in this case, we don't want to create more difficulties for them, and they just like to write their Python applications. They don't care about S3 APIs. But there could be cases that are different. So yeah, this is another point why maybe we should keep them separate. Although, I mean, there are reasons to not keep them separate, or at least there are other.
I think the likelihood of coming up with an API that extends a SEP API for S3 that does this is being largely successful is slim to none. That said, MinIO just came out with their own way of doing this. It has nothing to do with what. It just says prompt me and I'll type in some objects and then it'll tell me things.
Yeah,
so incredibly vague.
Yeah, that would be that. In my opinion, that would be taking it way too far. So a prompt API does not make sense to me. But a search API is kind of one level below that. So I'm not gonna switch whatever does the prompting, but makes a little more sense, I think.
Well, I'm not very. I'm intuitively skeptical that making things look like each other is making applications and storage look the same. It helps. I think it's distinct from, say, predicate pushdown, where you have a very reusable set of properties that lots of applications would consume. It just feels like this is more. At least when you look at it, it just feels like these are more applications using storage. Whereas the usable capability is notifications or it's function embedding, Lambda or predicates or something.
Yeah, I mean, I kind of tend to agree that. So for sure, I think that prompt is taking that couple levels too far and makes little
It's
sense
definitely
to me.
there. I mean,
regarding search, I also agree that would be very difficult to compete with. I don't know, Milvus search is not very complex, but things like pgvector, they have their search API, which is actually an SQL API, and for sure we're not going to compete there. So I don't know. I would like to get some to try and gather some feedback from actual users of such systems and see what they have to say about that.
Yeah, I think I tend to agree with Matt's position there, but maybe instead of integrating in RGW itself, we could do more in Rook or Kubernetes just to make kind of a more consistent configuration setup.
Yeah, that's compelling.
Kind of visible to clients similarly.
That seems really compelling. I mean, figuring out how to do the integrations in a more automatic way.
Oh yeah, I mean, here we don't have an operator, so everything is pretty manual. Like you've seen that the name of the collection is going to fetch from the logs. Of course, this doesn't really work in real life. But I mean, once we have that properly as an operator, then maybe for sure there'll be like an API to fetch the name of the collection, and similarly there could be an API to fetch the name of the embedding function and maybe other information that is important for the client. So they can, make sure that they don't have configuration mismatches there. Anyway, thank you for the feedback. I think Jiffin has plans to present that in a couple of conferences, and maybe get some feedback there from people that are not, in the storage business, but more in the data science or AI business, and see what they have to say.
Very cool. Thanks, Yuval and Jiffin. Want to make sure that we have time for Igor to present, but any final comments on this?
It's cool. Thanks for doing the work.
All right. Igor, are you there?
Hello, can you hear me?
Yeah, hi. Take it away.
Hello. Okay, so first of all, I would like to give some background to describe the issue that we are facing, that we are trying to solve. And then if necessary, I can show the drawing that I have, which I just basically created for myself to better understand how the implementation works, if we even need to get into that. But First, let me describe the problem. So the current versioning system in RGW relies on two things. First one is object key, which is basically a combination of name and version/instance ID. And the other one is version object epoch, which is an 64-bit integer value. So the conflicts can arise over the normal course of operations when, due to racing rights to the same object, the object's current epoch may be equal to a pending epoch that is associated with incoming changes to that same object. So in such cases, current implementation resorts to doing a lexicographical compare of the current version ID and the incoming version ID. And given that those are generated randomly, the winner is also picked randomly. So this presents a problem for multi-site deployments, as it can lead to a divergent object history between the primary and secondary zones, for example. So in case of a DR event, disaster recovery event, when we need to swim between zones, users can be presented with a different object modification history. So if everyone agrees with the background on this, before I propose the solution, if there are any questions or any comments on this, has this been properly identified?
So the kind of mismatching histories, is that where does that show up as a problem? Is it just deciding which version should be current?
That is deciding which version should be current. That is one of the things. But for example, if user wants to roll back the history, let's say, for whatever reason, wants to restore some older versions, right? So then they may have to go through a different version modification history in case they swim between one zone and the other.
Okay, if you delete the current version, then it has to backtrack to the next current.
Yes, exactly.
Got it.
Okay, so if no other comments, the solution that I want to propose, and this is based on the suggestion by Huda, is to use timestamps instead of epochs. What the timestamps will allow us to do is maintain the same object history in both zones by carefully slotting those modifications into object history in each zone. Let's say when they are getting replicated in active-active setup. Thus keeping the object history identical between zones. So even with that, even with time-based epochs, there is still possibility of simultaneous updates happening to the same object, however small that might be. In this case, we have to decide how to resolve the conflict if the timestamps are identical. One way is to use something like a cluster or zone or even bucket-wide config setting that says something like, always pick the change from the master zone or the one coming from the secondary zone or something like that. Of course, there can be other options beyond that one, like if both changes are coming from the same zone, from different RGWs, for example, then we have to figure out something else. But the goal should be the same. We need to produce a consistent modification history of objects in each zone. So that is the solution, and that is the description of the problem. And what I wanted to hear is like any feedback or suggestions.
Yeah, so it sounds like you're using a timestamp in place of the OLH epoch.
Yeah, which is an integer value.
With the OLH epoch, we were using the key name lexicographically as the tiebreaker.
Yeah.
What is the problem with doing the same with timestamps?
First of all, timestamps give us higher resolution than just integer epoch, because we can pinpoint exact moment in time when modification took place in different zones. So we can slot them in the object history appropriately, which is impossible with integer epochs, right? Because you don't know which one took place.
But I'm not sure what are the requirements for time sync between zones. But
I spoke with Yehuda, and he said that basically we rely on NTP, the assumption is NTP is at least is in place.
Yeah, but NTP doesn't give you like microseconds.
Yeah, I
here,
understand.
right?
Yeah.
So I mean, you will have you will make the wrong decisions, anyways.
It is possible.
Well,
Yeah.
that could arise anyway. We were using timestamps for other equivalence checks in multi-site at the moment.
Yeah, in the presence of time skew, there isn't necessarily a right decision. There's just, can we guarantee that all zones converge to the same result?
Though in fairness, because the way CLS works in practice, a lot of our time sequence stuff is actually done on the same clock, because it's generally comparing. I mean, it doesn't always happen. If an OSD goes down, it can go down, but in general, we're always comparing. In general, in CLS at least, we're always comparing the clock on the primary OSD of the PG against the clock on the primary OSD of the PG. So in that general case, so in that specific case, which often happens, there isn't actually going to be time skew.
But those could be two different Ceph clusters.
Oh, I know. I was answering the what we do now part. Like
So many,
specifically.
even now, the two zones, right? They could.
Yes, that happens.
They could
Oh, yeah.
be completely.
Yeah, in two zones, if there's time skew, the one that has the higher timestamps is generally going to win.
Well, yeah. So, but in this case, we are going to actually put all the modifications if the timestamps are not the same, if they are not identical. They will all be in the object history, regardless of the zone they happen in, even in the presence of the clock skew, time skew. So I understand that this is not the ideal solution, but this is better than relying on integer epochs. Unless you have a better suggestion, of course.
No, I do like timestamps here. Backing up, I was just restating what I said. Currently, we're using OLH epoch for ordering and key names as a tiebreaker. So I was suggesting that we continue using key names as a tiebreaker, but use the high resolution timestamps instead of the epoch.
But what are you going to do in case when we have two identical timestamps? Who is going to be the winner?
The one whose key or instance name sorts higher or lower, whatever we choose.
Yeah, we can keep that, but why not go further and have a configuration that says exactly who we want to pick? Like we want to pick this zone over master over secondary, instead of relying on the random string. Wouldn't that make more sense in some cases?
What cases are you concerned about where an admin would want to control?
Yeah, like, so let's say you always prioritize object modifications happening on the primary versus those happening on the secondary. Should the unlikely event happen and the two timestamps are identical, which I expect to be rare. So for now, we can just keep it the way it is. Like you suggested, we just rely on the lexicographical compare. But going further, we could introduce this configuration. But this is kind of an optional thing, I guess.
Why is it further? Why is it better?
Because in some cases, you might want to have more control over who wins
But it's
over who.
it's not a very good control. it's just sort of saying this guy always wins. It sounds like what you're proposing. This
Yeah,
whole
if you want
zone
that.
always wins. I don't know why I would favor that. Maybe it's more stable in some sense, but it's not more accurate.
Yeah, and I mean, you still have the problem where the master zone or primary zone is racing with itself with object versions, and then you'll have to fall back to another tiebreaker. So yeah, I don't know. I feel like this is kind of orthogonal to what we use as the initial ordering And for data sync in general, there isn't necessarily a primary secondary distinction. It's generally active, right?
Yeah, but you can like specify like a zone name and say this one wins over the other ones. I don't know. That was just a suggestion that came up during internal discussions about how we want to solve that.
I think that maybe it makes sense for data, like for disaster recovery, for an active case. I don't see. I mean, you won't be able to control something that is ongoing all the time, right? It's not like you're gonna have a decision point. Oh, I'm going to restore my failover somewhere, and then you're going to make the decision. If you have an active case, then
You still have a zone name, right, or zone ID?
Yeah, but the admin doesn't know which zone failed and which zone didn't fail. Like there'd be no like it wouldn't be knowledgeable making the right decision of which zone should win.
Well, you mean that once we swing from between the zones, those configuration rules will no longer apply?
Yeah,
because the primary is going to be something else. Yeah, I agree that this solution has drawbacks, but I thought I would mention it anyway.
And I think, I mean, if we're going to use a timestamp, then the collision rate is going to be much lower anyways.
I expect it to be. I'm not sure what the resolution of the clock is. Is it milliseconds? Is it microseconds? That Ceph is using?
Adam, is it nanoseconds?
Okay, so then
Sorry,
should be exceedingly. What is the resolution of the clock that Ceph is using?
It's using the timestamp itself is a 64-bit nanosecond count. But the underlying precision of the clock is whatever the underlying precision of the clock is. Right now, we either use monotimer or real clock for things where timing is important, which should be set up to use the most precise system clock. Well, the clock that is most precise on the system. And there's pardon me. And there's also coarse clocks that are whatever. But you'll get nanosecond timer to whatever, or precision to whatever your clock will give you.
Okay, so I guess in this case, we want to use the highest resolution clock available so that we minimize the conflicts, right?
Well, you,
But that
you want to be using the real clock, the clock real
Yeah, you
time,
want to use Ceph real clock.
which is already the case. But maybe if you're adding it, but yeah, you want to be using what we call Ceph real time, real clock.
Okay, I'll keep that in mind. Okay, so with that conflicts, I doubt we will ever see them if the resolution is like nanoseconds.
I have another question.
But in case, yeah.
Sorry, so we're thinking what's going to happen on a live system, like when we upgrade. There going to be two different mechanisms for different objects, or for the same object, or different versions of the same object.
Yeah, I guess we're gonna have to build in have a solution for that to fall back in case we discover that, let's say we have a OLH entry for an object that has uplog and that contains integers instead of time values. I haven't really thought through that yet, but I see that that could be a problem. Yeah, we have to think about that. But then the consensus is that we're not going to do the configuration that decides who the winner is, and we're just going to replace the integer with a real-time clock and use the key comparison as we do today, but we're going to use the time value instead of the integer. Did I get that right?
That sounds good to me. I think we could discuss separately improvements to the tiebreakers, but yeah, I don't think that's critical to fixing this bug.
Yeah, given the high resolution of the clock, I think that's going to be exceedingly rare. So I think we should be good to go with just replacing the integers, the time values.
Yeah, so I think the complexity is just going to come from designing this so that it's backward compatible.
Yeah.
Potentially like newly created OLH entries could have a special flag or something saying this is based on timestamps.
Mm-hmm. Okay, I wonder if, so we're gonna have to have that flag in terms of like bitwise. So the current value is 64 bit. The high resolution clock, is it also taking up 8 bytes in memory? So there won't be any changes in data size, right?
Correct.
Yeah, but we still have to know how to treat those 8 bytes. Is this an integer or is this a time value? So yeah, so that's it. I mean, that's all I had to talk about for today. And if everything makes sense, then I'll go ahead with the implementation.
Thank you, Igor. Any other thoughts here? Any other topics for the agenda then? All right. Thanks, everybody. Goodbye.
Bye bye.
Mm.